Okay, I have one the so I'll just write the equation here. So we have sigma cube minus I1 sigma squared plus I2 sigma minus I3 equal to 0. So that's your equation there. We have an equation for the invariance. So what will be your first value here? For your first invariant, I1. 13, okay. And then you have your I2, negative 600, okay. And then you have your I3, negative 8,000. So what do you get as a stress? I mean your principal stresses. So you have now sigma 1. So what's sigma 1? So that's 40. Sigma 2, 10. Anybody from the back? And then your sigma 3, negative. I have this one to be negative 20. Is that okay? So we got negative 20. Now the thing is that what's the importance of invariant? So the invariant, if you're comparing two stress tensor or state of stress, if they have the same principal stress, then they will be the same. But going back to a more detailed analysis, if you have two tensors, they may have different values here, state of stress, but if they have the same invariance, then you know they are the same. Okay, so that's the importance of this invariance. So rather than going directly to the principal stresses and comparing two stress tensors and saying that they are the same because they have the same sigma 1, sigma 2, and sigma 3, then you probably can simply look into the invariance. So this invariant will change for the same tensor. So you can rotate the tensor in different directions and so on. But if their invariants are the same, I1, I2, and I3, you can conclude that they are the same state of stress. They just have different rotation, but they have they are the same, practically the same. Okay? So with that, I think if you want to know your deviatoric tensor, you have first to determine your hydrostatic stress, yes? So we have a full house here, so this will be, since both are zeros, then this one is 10, yes? And then of course, you have now your deviatoric tensor, so that will be Sij. So that is 30 minus 10, that is 20, 10. Okay? So that's your deviatoric tensor. So we normally use the deviatoric tensor for the plasticity analysis in the plasticity region. So elasticity, for some reason, is not really something important. So please proceed with the others. So let's look at number 2. So please have a look at number 2.